Have you ever wondered why time seems to move forward? It's a curious thing, isn't it? You see, in the vast universe we inhabit, time isn't as straightforward as it feels. We experience it as a constant flow, always pushing us toward the future. But could we actually swim against this current and reverse time itself? Let's dive into the fascinating world of physics and find out. Time travel has captivated our imaginations for centuries. From H.G. Wells's The Time Machine to the iconic DeLorean in Back to the Future, science fiction has gifted us with thrilling possibilities. These stories often portray time travel as simple as hopping into a machine and inputting a date. But in reality, reversing time is far more complicated than fiction portrays. While the idea of altering the past or peeking into the future is intriguing, the scientific reality is much more grounded. It delves into the fundamental laws of physics, particularly those governing time and space. Could we really rewrite history, or are we bound by the constraints of the universe as we know it? One of the biggest hurdles in reversing time is a concept called entropy. Entropy is like a cosmic rulebook that dictates disorder always increases over time. Think of a shattered glass. It's easy to break, but putting it back together exactly as it was is nearly impossible. That's entropy at play. It gives time its direction, often referred to as the arrow of time. Now, let's take a closer look at this thing called entropy. Imagine a pristine, organized room. Over time, it naturally tends to become messier, right? That's entropy in action. It's the idea that disorder or randomness increases in a closed system. This principle extends to the entire universe. As time marches forward, entropy increases. Think about a burning log. Once it turns to ash, it can't spontaneously revert to its original form. This irreversible process is a testament to entropy's power. It suggests that reversing time would be like trying to unscramble an egg, incredibly difficult if not impossible. But what does this have to do with time travel, you ask? Well, if we were to reverse time, we'd essentially be attempting to decrease entropy, to bring order back from chaos. And as we've seen, that goes against the fundamental laws of physics as we understand them. So, entropy poses a significant challenge to the idea of time reversal. It suggests that time might have a preferred direction, always flowing from a state of order to disorder, making it very tricky to turn back the clock. Now let's unravel the mind-boggling concept of causality. It's the fundamental idea that every action has a reaction, a cause and effect relationship that governs our universe. It's like a cosmic game of billiards where one event triggers the next in a predictable sequence. But when we talk about reversing time, things get a little messy with causality. Imagine traveling back in time and accidentally causing an event that prevents your own birth. If you were never born, how could you have traveled back in time in the first place? This is known as the grandfather paradox. These paradoxes highlight the potential for logical inconsistencies when we try to tamper with the past. They challenge our understanding of cause and effect, suggesting that altering the past might create ripples in the fabric of time with unforeseen consequences. While these paradoxes might seem like plot devices from science fiction, they underscore the very real scientific challenges of time travel. It's a bit like trying to solve a cosmic jigsaw puzzle where the pieces constantly shift and change. But what about time itself? How does it fit into the grand scheme of the universe? Well, Einstein's theory of relativity completely revolutionized our understanding of time. He proposed that time isn't absolute, but rather relative to the observer's motion and gravitational field. Imagine two clocks, one stationary on Earth and the other traveling at incredibly high speeds through space. According to Einstein, time actually slows down for the moving clock relative to the stationary one. This phenomenon, known as time dilation, has been experimentally verified, proving that time is not a constant but rather a fluid concept. Einstein's theory also revealed the interconnectedness of time and space, merging them into a single fabric called space-time. Imagine a bowling ball placed on a trampoline. It creates a dip, distorting the fabric. Similarly, massive objects in space like stars and black holes warp the fabric of space-time, influencing the flow of time around them. So, time, as we perceive it, is intimately connected to gravity and motion. It's not a rigid, unchanging backdrop to our lives, but rather an active participant in the cosmic dance of the universe. Now let's dive into the even stranger world of quantum mechanics. This branch of physics deals with the super tiny, the realm of atoms and subatomic particles, and let me tell you, things get really weird down there. One of the most mind-boggling aspects of quantum mechanics is the idea of superposition. Imagine a coin spinning in the air, not yet landed on heads or tails. In the quantum world, particles can exist in multiple states at once, like that spinning coin, until we observe them. Then there's quantum entanglement, particles linked together in a way that even if separated by vast distances, they still influence each other instantaneously. It's like two coins flipped far apart, always landing on the same side, a spooky connection that baffled even Einstein. Now, how does this relate to time travel? Some physicists believe these quantum quirks might hold the key to manipulating time itself. Imagine if we could exploit these strange quantum phenomena to influence the past or future. While still highly speculative, the realm of quantum mechanics offers a glimmer of possibility for circumventing the limitations imposed by classical physics. It's like discovering a secret passage in the cosmic house of time. We've explored the challenges of entropy, causality, and the mind-bending nature of time itself. But amidst these seemingly insurmountable obstacles, there are glimmers of hope, theoretical loopholes that might allow us to bend, if not break, the rules of time. One such concept is wormholes, theoretical tunnels that connect two distant points in space-time. Imagine folding a piece of paper in half and poking a hole through it. That's a simplified way to visualize a wormhole. By traversing this shortcut, we could potentially travel vast distances even through time itself. However, wormholes are still very much theoretical. They require exotic matter with negative mass energy density, something we've never observed, to keep them stable and traversable. Then there's the concept of time crystals, mind-boggling structures that have atomic arrangements that repeat in time, not just space. Imagine a clock that never needs winding, constantly ticking without any external energy source. That's the basic idea. While still in the very early stages of research, time crystals could revolutionize our understanding of time and its potential for manipulation. Imagine harnessing their unusual properties to control the flow of time itself. Now, some theories suggest that traveling to the past might be possible, but with a catch, we might be restricted to a closed loop of events. This means we could potentially revisit past moments but not alter them in a way that changes our present. Imagine watching a movie for the second time. You already know what's going to happen, but you can't change the plot. Similarly, in a closed loop, we might be mere observers of the past, unable to rewrite history. This idea, while limiting, offers a resolution to the paradoxes we discussed earlier. It suggests that the universe might have a self-consistency mechanism, preventing any changes to the past that would disrupt the present. So, while we might not be able to hop in a time machine and alter history at will, the possibility of witnessing the past firsthand remains an intriguing and potentially achievable goal. Imagine the secrets we could unlock, the mysteries we could unravel. For decades, the concept of reversing time seemed as far-fetched as a unicorn riding a rocket ship. But recent breakthroughs in theoretical physics have injected a dose of tantalizing possibility into the equation. One groundbreaking theory that's turning heads in the scientific community comes from the brilliant mind of Dr. Ron Mallett, a physicist at the University of Connecticut. Dr. Mallett has dedicated his life's work to unraveling the mysteries of time travel, driven by a deeply personal motivation, to reunite with his beloved father, who passed away when Dr. Mallett was just a boy. Dr. Mallett's theory centers around the idea that by creating a rotating laser beam, we could potentially warp the fabric of space-time, creating a loop in time. Imagine twisting a straw into a loop. That loop, in Dr. Mallett's model, represents a pathway to the past. Now, before you rush out to build a time-traveling laser in your backyard, it's important to note that Dr. Mallett's theory, while mathematically sound, still faces significant practical challenges. Remember those mind-boggling quantum quirks we talked about earlier? Well, they might just hold the key to unlocking time travel's secrets. Some physicists believe that by harnessing the bizarre properties of the quantum realm, we could potentially manipulate time itself. Imagine a computer that could operate not just in the realm of ones and zeros, but in the realm of quantum superpositions, existing in multiple states at once. Such a quantum computer could potentially process information at an unprecedented scale, unraveling the complexities of time travel with ease. And then there's the curious case of quantum entanglement. Remember those two linked particles influencing each other instantaneously across vast distances? Some physicists theorize that this spooky action at a distance, as Einstein famously called it, could be exploited to send messages or even particles backward through time. While still highly speculative, these quantum avenues offer a glimmer of hope for circumventing the limitations imposed by classical physics. It's like discovering a secret passage in the cosmic house of time, a passage that might just lead us to the past. Now let's revisit that mind-boggling grandfather paradox. If we were to travel back in time and prevent our grandparents from meeting, would we cease to exist? It's a question that has plagued philosophers and physicists alike for decades. But what if the answer lies not in preventing paradoxes but in embracing them? Some physicists propose that time travel might not allow for changes to the past that would create contradictions. Instead, any attempt to alter the past would simply lead to a new, consistent timeline branching off from the original. Imagine tossing a pebble into a pond. It creates ripples that spread outward. Similarly, any action taken in the past, even something as seemingly insignificant as stepping on a butterfly, could create ripples in time, leading to a vastly different present. This concept of multiple timelines, while mind-boggling, offers a potential resolution to the grandfather paradox. It suggests that time travel might not be about changing the past we know, but about exploring the vast, uncharted territory of all possible pasts. As we've journeyed through the cosmos of time, we've encountered mind-bending concepts, from the relentless march of entropy to the quantum realm's bizarre possibilities. It's clear that reversing time isn't as simple as hopping into a DeLorean and inputting a date. It's a puzzle box of cosmic proportions, with pieces that constantly shift and change as we delve deeper. While the laws of physics, as we currently understand them, present formidable challenges, they also offer interesting clues. Could wormholes, those theoretical shortcuts through space-time, one day become a reality? Can we harness the strange powers of quantum mechanics to bend time to our will? These are questions that continue to ignite the imaginations of scientists and dreamers alike. What we do know is that the universe is full of surprises. Just when we think we've grasped the fundamental rules, a new discovery sends us spiraling down a rabbit hole of even deeper mysteries, and that's what makes the pursuit of knowledge, particularly in the realm of time travel, so exhilarating. So, what does the future hold for time travel? While we may not be hopping into time machines anytime soon, the quest to unravel time's secrets is far from over. Scientists around the world are pushing the boundaries of physics, exploring new theories and conducting groundbreaking experiments that could bring us closer to understanding the true nature of time. Imagine a future where we can send messages to the past or receive glimpses of the future. Picture a world where time travel is no longer confined to the realm of science fiction, but is an integral part of our understanding of the universe. While such a future may seem like a distant dream, the seeds of possibility have already been sown. As we continue to explore the cosmos both within and beyond ourselves, we may find that the greatest journey of all is not through space but through time itself. The quest to understand our place in the grand tapestry of time is a journey filled with wonder, challenge, and the boundless potential for discovery. I hope this deep dive into the science of time travel has left you with more questions than answers. That's the beauty of science. It's a never-ending quest for knowledge, a journey driven by curiosity and wonder. What are your thoughts on these mind-bending theories? Do you believe time travel will one day be possible? Share your thoughts and theories in the comments below. I'd love to hear your perspectives on this fascinating topic. And as always, thank you for joining me on this adventure through the cosmos. If you enjoyed this exploration of time travel, don't forget to hit that like button and subscribe to Time Pilgrimage for more mind-expanding journeys into the universe and beyond. Until next time, keep exploring.